Hello, and welcome to the relearning for Algebra 2 trig on the 6 trig functions and the right triangle trig word problems. Okay, here is a video about the 6 trig functions.
We've been using and seeing the trigonometric ratios sine, cosine, and tangent as they apply to a right triangle. And we've defined them to be sine being the opposite side divided by the hypotenuse, cosine being the adjacent side divided by the hypotenuse, and tangent being the opposite side divided by the adjacent side. And those we abbreviate with the first 3 letters, SIN, COS, TAN, but the full words are sine, SINE, cosine, and tangent. If you think about the 3 sides, opposite, adjacent, and hypotenuse, there's other combinations that we could put them together in besides these 3 fractions. And for those other combinations, we have other names. So there are actually 6 different ways that we can put the sides together in pairs, one on top of the other. Opposite over hypotenuse, well, we could also do hypotenuse over opposite. And instead of adjacent over hypotenuse, we could do hypotenuse over adjacent. And instead of opposite over adjacent, we can do adjacent over opposite. So these can just get flipped over, and once we do that, we've got every possible combination of 2 of these sides being put together in a fraction. The names that we give these other combinations are secant, secant, cosecant. So just like we had sine and cosine, we have secant and cosecant. And then tangent, we also have cotangent. Secant, cosecant, and cotangent. And we abbreviate these just like we abbreviate sine, cosine, and tangent with the first 3 letters. We do the same thing here. Secant is the name that we give to the hypotenuse divided by the adjacent. So we're going to use SEC, secant of the angle, is the hypotenuse divided by the adjacent. Sine is opposite over hypotenuse. Hypotenuse over opposite, that's cosecant. I've got a problem here. If I use the first 3 letters, COS, well, then it looks like cosine. So in order to tell it apart, we instead use CSC for each of the syllables. It's the first letter of each syllable. Co, C, cant. And then cotangent, we use COT. And we've got cosecant, secant, and cotangent. Hypotenuse over opposite, hypotenuse over adjacent, adjacent over opposite. If you use SOHCAHTOA.
Okay, so let's take a look. So we have in here our 6 trig functions. So looking at in here, we have a cotangent. So tangent is in the name. And so we're going to be looking at this. We're looking at tangent first, the tangent of theta. So we have SOHCAHTOA. SOHCAHTOA. So tangent is opposite over adjacent. Opposite over adjacent. So cotangent of theta is adjacent over opposite. So we need to know what adjacent, opposite, and hypotenuse are for our figure that we have right here. So this is our reference angle. Our B is our reference angle. We're going to go directly across from there. Our directly across gives us our opposite. And then across from our 90-degree angles. Now, all these things only work, cotangent, tangent, and sine can only work with right triangles, same with secant, cosecant, and cotangent. But so we have a 90-degree angle right here, and we have a hypotenuse. And then the one that's left is our adjacent. So we go back over to our top, cotangent of theta. Whatever the angle measurement is for B is our side length adjacent, which is 4/3. 4/3. Looking at our cosecant, we have our cosecant is associated with our sine. So looking at our sine of theta is our opposite over hypotenuse. So cosecant of our angle measurement is going to be hypotenuse over opposite. So we have to do the same thing. We have our reference angle here, and our reference angle is B, and we do the same thing. The one that's across from our reference angle is our opposite. The one across from our 90 degrees is our hypotenuse, and the one that's left is our adjacent. So we go over here, the cosecant of that angle measurement is 5/3. Okay, next we have the secant of A. So now we have a different angle measurement. So we have to check out where our angle measurement is. Here's our A, and we're going to take a look in here and do our opposite, adjacent, and then a hypotenuse again. So this one is directly across from A. This down here becomes our opposite side. We have our 90-degree angle. Again, they only work, this method with the SOHCAHTOA is only for right angles. I'm going to go across from here, and the one across from our 90-degree angle is always the hypotenuse, and the one that's left is the adjacent. So SOHCAHTOA, and so looking at secant is related to our cosine. Our cosine of theta is adjacent over hypotenuse. So looking at this now, we know that the secant of our angle measurement is going to be hypotenuse over adjacent. So looking at this, the secant of our theta is our hypotenuse, which is 37, over our adjacent, which is 35. All right, so we're going to look at right triangle trig word problems. Right triangle trig word problems. So in here we have a rock. Over here, a rock, and it's 20 feet away from the tree. Now, when it just says the tree, it doesn't say the top of the tree. It would have to specify if it were the top of the tree. So down here, this line length is 20 feet. And the tree is 50 feet tall. So we want to know the angle of elevation. And the angle of elevation is always down here. It is the angle opposite our right angle. Here's our right angle. So we have two choices. We have up here in the top or down here, and it's always down across from our horizontal line. So we take our horizontal line and move up, and that's our angle of elevation. So looking in here, we have a right triangle, and we're looking at, we need to do our A, H, and O. So this is our reference angle. So across from here is our opposite. Across from our 90 degrees is always our hypotenuse. And the one that's left is our adjacent. So looking at this, we need to figure out which one we're going to do. So we look again at our SOHCAHTOA. So in here we have opposite and we have adjacent, which means that we are going to look at tangent. So the tangent of the angle measurement, whatever it is going to be opposite over adjacent. Opposite over adjacent. So now we need to figure out what that angle measurement is. So the tangent of theta is 50 over 20. So we need to figure out what that ratio turns out to be. So looking and dividing 50 by 20, and we get 2.5. So the tangent of that angle measurement is 2.5. So now we're going to look at the inverse or the arc tangent to get the angle measurement of 2.5. So we go on our calculator, we do second tangent, put in 2.5, punch it in, and our angle measurement is 68.1 degrees. It's a degrees because it is an angle. Taking a look at our next one, we have a ladder. What is the measure of the tilt of the ladder? Tilt is another word that we would use for our angle measurement. So in here, we're looking for the tilt of the ladder, which means that we are moving our ladder and it's not straight up and down. We're moving it towards our building or our wall. So how does this all look? Again, we're looking for the angle measurement. So we're in here, we're going to take a look and we have our angle, our reference angle. So the one across from here is our opposite side. The one across from our 90 degrees is always our hypotenuse. And the one that's left, that's right next to our angle, is the adjacent. So looking at our SOHCAHTOA, we're going to be looking at this in here, and we have values for the adjacent and for the hypotenuse. So that means that we are going to be doing our cosine of our angle measurement, which is adjacent, which is 6 over 16. 6 over 16. So we're going to do the cosine of theta of 6 divided by 16. So let's just put that right in there. 6 divided by 16 gives us 0.375. The angle measurement is the inverse or the arc sine of 0.375. Second cosine 0.375 gives us theta equals 68.0 degrees. It really is 67.9756. And you can see all those roll up to basically 68. You could do 67.98 or 68 degrees, depending on what it's asking you to roll, what it's asking you to round to. The last one, we're using the same thing, and we're going to see if we can find out how high up the ladder is on the wall. So the angle measurement doesn't matter. So in here we have our three sections in here. We have our right angle. Now we can do SOHCAHTOA and we can do all of the sine, cosine, and tangents. But really, when you have three values like this, three side lengths, and we're looking for the third side length, we're actually talking about the Pythagorean theorem. So in here, we don't need an angle measurement to find the third in here. So 16 and 6, and we have our wall measurement. These are all side lengths, so we can go straight to the Pythagorean theorem. The one across from our hypotenuse is always C. We have A and we have B here, or you could switch the A and B around. It doesn't matter, but it does matter that the C is the longest side. So we're going to have A squared plus 6 squared is equal to 16 squared. A squared is equal to plus 36 is equal to 16 times 16 is 256. Subtract 36 from both sides. A squared is equal to 220, and take the square root of both sides. And you get that A is equal to 14.8, and our measurement is feet. So this length of the wall right here is 14.8 feet. Now we know that that's true because of the fact that we are the 16-foot ladder, when it leans over, it has to make sense that it's only 14 feet up our wall.